Companies absolutely love binary search. Just take a look at all the companies that have asked this question lately. And here's the question. You're going to be given a sorted array, except that it's going to be rotated, and you're going to have to find the minimum number in that array. Take this array, for example. This is definitely sorted, but it has been rotated, and you're supposed to find the minimum number, aka 0. Oh, and you have to do it in log of n time, so you can't simply walk the array, as that is going to be O of n time. The intuition for this problem is straightforward. We are going to be using binary search to find the pivot point. And whenever we're updating the search space, we have to keep in mind that the pivot point is going to be in the unsorted part of the array. Here's the solution to the problem. If there's only one element, we return that element. Otherwise, we get our left and right pointers and dive into binary search. Before we dive into anything else, if we find the search space is sorted, we return the leftmost element. Otherwise, we calculate the midpoint of the search space and try to see if the pivot point exists at or around the midpoint. For example, if the element before the midpoint is greater than the element after the midpoint, then the midpoint must be the pivot point. Because remember, the elements are going to be in ascending order everywhere else other than around the pivot point. Likewise, we check to see if the element right after the midpoint is smaller than at the midpoint to see if this is the pivot. If we're unable to find the element this way, we update the search space to the part around the midpoint that is unsorted. Binary search, so the time complexity is O of log n and the space complexity is O of 1.